All right, this is our last video in the under the topic of systems of linear functions, systems of linear equations. But specifically on this one, we're looking at systems of linear inequalities. Okay, and we're going to start off with an introduction and then do a couple examples in this video. So our goal here is to graph some overlapping linear inequalities. Usually you have a couple of them, but often you might have 3 or 4 or even more. And the solution to one of these problems is the overlapping region that fits all of the linear inequalities you're dealing with. Okay, so you're looking for where there's some regions that are in common to the linear inequalities that you're graphing. And so your answer is usually a graph with a clearly highlighted zone of kind of the final highlighted, or the final region of overlap. Let's do an example. So for this first one, we're going to graph the following systems of linear inequalities, where we have a y is greater than or equal to 2x minus 1, and then also y is less than 0.5x plus 4. And I'm going to try to be careful with color coordinating here. Let's have this first one be green, and let's have this second one be blue. Okay, so I'll try to separate those by color. So for the first one, y is greater than or equal to 2x minus 1. That is going to be a solid boundary line within with a boundary of y is equal to 2x minus 1. So that means we have a y-intercept of -1 and a slope of 2. And we could continue in both directions. And let's try to draw a line and try to make it nice and straight if possible. And it says y is greater than or equal to that. So I'm going to assume we're shading above, but you always want to be careful by testing a point. And I'm going to test that point 0, 0. Is 0 greater than 0 minus 1? It is. So I'm going to shade this zone right here. And you don't have to fill in 100% of your shaded zone, but you just want to make sure it's clear to, let's see here. You want to make sure it's clear to the reader or to your teacher what zone you're talking about. Okay? Let's do the next one. Y is less than 0.5x plus 4. And so that's going to be a dotted line with a y-intercept of 4. 1, 2, 3, 4. And a slope of a half. So up 1 over 2, up 1 over 2, up 1 over 2 in both directions. And in my app, it's challenging to do a dotted line. I'm going to do my best, but just make sure if you're doing this on paper, you're using a ruler and trying to make a nice, clean dotted line. Okay. And then we are shading the zone below, I think, but again, let's test that and check to make sure. Are we shading the zone including 0, 0? Is 0 less than 0.5x plus 4? It is. So we're going to shade this zone in here, to shade the zone below that line. Okay? So we have 2 overlapping zones, and our final answer is the region that both zones overlap in. Okay, so to be very specific, let me shade this in black then. Our final answer is this zone right in here. Okay, and if you're doing this on a piece of paper and you're turning it into your teacher, you just want to make sure you're clear about which zone is the final answer, and you don't have to take 10 minutes to fully shade it in. Sometimes students like to do that, but something like what I just modeled, I think, is a good final solution here. All right, let's move on to the next one, and we are going to be starting with a graph. So we're going backwards now, okay? So what if we have the graph and we're looking for the system of linear inequalities? So we can keep color coordinating. Let's work on our blue equation first. And so it looks like we have a nice y-intercept down here, and it looks like we have a slope of -2, okay? So we have y and I think it's going to be greater than, but I'm going to check, negative 2x minus 3. Okay, so we know that the origin is included in the shaded blue zone, so let's plug in the origin into that inequality. Is 0 greater than negative 2 times 0 minus 3? It is. Okay, and I chose to do a greater than instead of a greater than or equal to because it's a dotted line, a dashed line. Let's do the red one next. It looks like I have a y-intercept right here, and it looks like I have a slope of up 1 over 2. So I have a slope of a half. So y, and it looks like we're below the line, but I'm still going to check it with plugging in 0, 0. Y is less than or equal to, what do we say, 1/2 x minus 1. So I'm going to test the point 0, 0 here, but I don't want it to work because I can see that 0 is not included in my red shaded region. So plugging in 0, 0, up here is 0 less than or equal to 0 minus 1. It's not, it doesn't work, so that's good. We didn't want it to work. Okay. So it looks like we have a nice final answer right here to this problem. So that's our final system of inequalities right there. And that's a good place to stop for that one.